Hi, my name is Josh Bates and I'm going through the portfolio for my state level sprinter. I will be addressing the client's goals as well as my own, the consultation notes and the needs analysis that will be broken into physical and anthropometric factors, injury prevention, physical attributes and energy systems, as well as the action plan and the conclusion. The client is a state level sprinter looking to develop strength and power to decrease overall sprint times within the 200 and 400 meter sprint race, with the main focus on explosive power coming out of the blocks. The current training is 5 days a week on the track and 3 days a week in the gym, with most track sessions lasting between 1.5 to 2 hours. The client's goals is to decrease time in the 200 meter sprint from 21.86 seconds to 21.5 and in the 400 meter sprint from 48.2 seconds to 47.8 seconds. Also reducing the risk of injury and incorporating rehab-prehab into training sessions to ensure exercise are being done and complete. As a practitioner, my goals will be to limit the time that the athlete has in the gym so he doesn't lose motivation towards a resistance training program, creating a balanced resistance training program that enhances the client's track performance but doesn't facilitate overtraining, and allow the client progressive and overload progression through their pre and rehab exercises so the athlete has something to work towards and can see their success. The client's resistance strength training program is focusing on enhancing the client's strength, speed and power to enhance sprinting performance. The client is a 200 and 400 state level sprinter, with both races being broken into 3 different phases which include initial acceleration, maximum velocity and speed endurance and deceleration. The client has no current pre-existing medical conditions that influence or put the client at risk by performing a resistance strength program. This has been assessed by using the PAR-QNU and the ESSA pre-screening tool. Running efficiency in the explosive sport of sprinting will be a result from the development of leg strength, leg stiffness and explosive lower body power. Leg strength and explosive power from the sprint athlete is greatly determined by the ability of the nervous system to activate the correct motor units. Overall sprint times are a function of the initial acceleration, maximal velocity and the speed endurance, which are influenced by metabolic and neural factors, but also anthropometric factors. The anthropometric dimensions of all-time 100 meter sprinters were analysed to determine if there were ideal anthropometric dimensions for elite sprinting. The study concluded that among the top 50 elite sprinters, the mean height was 180 centimeters, body mass of 77 kilos, and a BMI of 23.7. Injury prevention is also just as important as enhancing sprint performance, with most hamstring injuries occurring during full speed running within the late swing phase and early ground contact phases. Testing hamstring concentric strength as well as quadricep concentric strength to produce a ratio of hamstring to quadricep can be extremely useful in predicting possible injury risk. Having a HQ ratio of below 0.6 significantly increases the risk of hamstring strain and injury by 17 times, reported by Young. Maximal leg strength is a framework of sprinters' speed and explosive leg power that needs to be at a mandatory level to be able to develop other areas of the race efficiently. National level sprinters performed several physical tests, with the first being 1 RM test of concentric half squat, which resulted with a mean value of 204 kilos. The second test was a counter movement jump, which had a mean height value of 36.5 for the 20 kilo load, also a peak force velocity of 2012.9 newtons and 4,809.3 watts of power. This demonstrates a relationship between strength and explosive leg power. During 200 and 400 meter track running, it is essential to use the ATP-PCR energy system by having a maximal initial acceleration phase to generate a high maximal velocity, while the dominant energy system is the ATP-PCR within the 10 seconds. Therefore, this decreases the potential time the athlete needs to depend on glycolysis for energy metabolism, which produces lactate and hydrogen ions as a byproduct. Lactate and hydrogen ions facilitate fatigue within skeletal muscle and as a result reduces maximum velocity and speed endurance performance. The first test for the client will be a 1 RM concentric half squat for the measure of maximal leg strength, with an end goal of achieving a 1 RM of 204 kilos. Test 2 is the counter movement jump, which will be used to measure the client's explosive power as well as force and velocity outputs, with the end goal being a height value of 36.5 centimeters, force output of 2012.9 newtons and a peak power output of 4,809.3 watts. The final test will be ensuring the client is maintaining muscular strength and balances and avoiding any preventable injury risk by assessing the concentric hamstring and quadriceps strength by using the isokinetic diameter, with a goal of 1 or greater to eliminate preventable risk of hamstring injury. As stated at the start, the client's goals are to increase sprint times in the 200 and 400 meter races, reduce chance of injury and include pre and rehab into his training sessions. The The PARQ and the ESSA pre-screening tool have deemed that the client is safe to participate within the exercise program without fear of injury. The literature has stated above that maximal leg strength and explosive leg power equal a greater running and sprinting performance. Also, stronger concentric hamstring strength compared to quadricep strength greatly decreases the risk of hamstring injury. Thank you for listening.